Thanks for joining me in this first expert series session we're doing here. So I guess I wanted to start by having you introduce yourself and tell us a little bit about what you do at Aoyue.
I'm Wilbert. I'm the head of the uh, R&D department of Aoyue International Limited. So I'm the one who's responsible for the day-to-day uh, uh, goings for design of new Aoyue products. Okay, so basically, normally we would have customers give us feedbacks, or our managers would set targets for what kind of new products they would like to set uh, to the market based on sales and some marketing research. And then when we get those data, then we would develop new products based on those.
Very cool. How long have you been at Aoyue?
For I think about 15 years, a little bit more than 15 years, maybe.
Yeah, we've been working with you since 2002, I think.
2002. Uh, a long time ago.
Yeah, it's been a while.
Yeah.
Um, so I want to get this out of the way. Almost every customer that calls into our customer service line always asks how to pronounce Oyu. So we just
Okay.
want to hear from you what the actual pronunciation is.
Well, it's actually uh, more of Aoyue. You can say Aoyue there. Yeah. Aoyue.
How are you? Okay.
Aoyue. Yeah. You can
How are
say Aoyue.
you?
Mm-hmm.
Yeah, I feel like here it's either Oyu or Ayu. Like an
Okay.
ah or an oi. And then
Yeah. Well, Aoyue. It's about it.
but
It's
some
about
people are
it.
like Oiui or like all over the place.
Yeah.
Um,
It's the what do you call a transliteration of the Chinese name. So it's,
yeah, does the name have a meaning behind it?
well, actually it comes from the Chinese name of the Olympics, which is Aoyun. Okay, and then it should be Aoyun. And however, during the printing of the or registry of the logo, there was a mistype on the Aoyun, so somebody mistyped it and then it became Aoyue. But because the product was already launching, there's no time to change it, so we stuck with Aoyue.
I think it kind of worked out for the better. What do you think? You think so? And it's like it's. I guess it's more. It's a unique name at
Mm.
least. How long ago did Oyu start?
So our year started, I think, 1997, right? It was our CEO or the founder of the Aoyue Tong Electronics. He started in a city called Shunde, okay, in China. Okay, so Shunde is actually one of the World UNESCO Heritage Site for City of Gastronomy. That's
Oh,
one it's known for. But another one is it's actually the home appliance center of manufacturing center of China. Okay, so back then, Mr. Tan, our founder, started manufacturing electronic tools or electronic drills, or what do you call the screwdrivers, electronic screwdrivers, and
okay, like
other
power drills and
uh,
stuff.
yeah, power drills, right? So mostly focus on giving the manufacturing tools needed for the expanding economy back then. Yeah.
So he, Louis Tan, he wanted to bring soldering tools to your local area, right?
Well, actually, there were soldering tools before, but most of it is what you would normally see those. I think how much does it cost now? $3 or $5 thing, which without the interchangeable tip, the one with external heaters. Okay, so most of the manufacturing factories use those. Okay, but as the electronics become more miniaturized, there was a need for more sophisticated tools. Okay, one of which is actually the hot air gun. Okay, before the hot air gun, there's no hot air gun manufacturer in China. Most of these hot air reworking tools have to be imported from other countries, like Germany, U.S., Japan. So there were actually no local manufacturers of this hot air rework system. So Mr. Louis Tan started development, and he was able to produce a locally manufactured hot air rework system.
Hmm.
So that was actually the first product of Aoyue.
Is that
Aoyue.
the
I'm sorry.
850?
Oh yes, 850 Aoyue.
Yeah, that's a good one. I think we're on the 852 A plus plus now.
Yes, yeah, that's right.
When you go to develop a new product, what kinds of things do you think about?
Um, well, we could. Um, I could give an example. If one of the, I think back in, I think the early 2000s, late 2000s, I think 2000. When was the Xbox? When did Xbox started?
That was.
I remember there was a time where there was the red ring of deaths for those console machines, right? And it started with Xbox, and PlayStation also had those errors. So um, one of the reasons they have those manufacturing errors is because back then manufacturers were transitioning from normal standard leaded solder to unleaded ones, or lead free solders. Okay,
Right.
so during the transition, okay, so well, the engineers there are still not familiar with the reflow profile of the uh, unleaded solders, so lead-free solders. So it seems that during the reflow of the BGAs, uh, it did not reach the correct temperature for full reflow. So what happens was that the contacts for the BGA and the motherboard of these PlayStations or Xbox uh, has what do you call, has only a slight there's a tendency for the connection to get lost. Okay, so it could be that the balls did not even melt. Okay, so maybe the out some of the outward BJ balls, solder bolts melted, the others did not. So it, but since it has some heat sink or some or during manufacturing it gets pushed in. Okay, so it could have a contact during manufacturing, but then after it gets to the customer, it gets heats up. Okay, and the heat would of course cause those virus problems. Okay,
Yeah.
so back then there was actually also a problem or some what do you call? So there are actually no tools that could handle those kind of boards, because first there were the first ones which has the lead-free process, okay, and then the BGA size and the PCB are multi-layered ones, so it's very difficult to get the heat in between the BGA and the boards. Okay, so the hot air system or the rework system before was just the 850 or the iteration of it, right? The 852, 852, 8 plus plus. So
Yeah.
in order to solve that problem, Aoyue actually developed the what we call the 732, the game console reworking system. Now, what's different about this product is that we actually developed a specialized square type, okay, square type IR convection system, wherein the heat comes out, or the infrared comes out in a specialized square nozzle that fits, okay, those BJs in those game console systems. And also there's a fan that is pushing the heat outwards. Okay, well, so what's different? What is different between this game console repair system, and the normal 850 or the hardware system? So for the hardware rework systems, the heating element is actually tube-like, cylindrical. Okay, for this game console system, actually developed the that's why it's called square type. Okay, we have what you call IR tubes inside. Okay, which would emit IR rays directly at the BGA. So uh, that's one of the heating that can get through to the BGA. The other one is the added forced air. So that forced air would engulf the entire BGA, so which would heat up the BGA faster. Oh, and then of course we have, of course, as you know, the Xbox and the PS has one of the larger type motherboards, right? So
Right.
paired with that, we had a very, back then, the largest size preheater on the market that could fit those game console system. Yeah. So,
Yeah.
well, that's how we develop things. There's a need for it in the market, right?
Yeah.
They need a solution, right? So we developed that specifically for it.
Yeah, I had a PS3, like a 40 gigabyte one from back when that came out, and I did get the yellow light of death.
Hmm.
And
Yeah.
at the time, I wasn't able to fix it, but that would have definitely helped.
Well, yeah, there were a lot of hacks back then. So some of them
Yeah,
was
hair dryer.
covering it with towels, right? Yeah, and blowing it with a hair dryer, and there were lots of different hacks to fix that. But of
Yes.
course, that only is a short fix. You really need to reflow those balls so that it could get a good contact.
Yeah. Yeah, I don't think putting it on the radiator is gonna really fix it.
Yeah.
So what was the evolution of your products like? Because you started with the hot air gun, like the 850, right?
We started with the hot air gun. Then, of course, the factories would be asking, well, do you have any other soldering solutions? Okay, one of the issues then was the factories are still using the old type external heating soldering irons. Okay, so the one with very pointy tip, very thin pointy tip. Okay, so those were a bit, let's say, they waste a lot of energy because uh, the heating element wraps around the tip. Okay, so a lot of heat is or energy is radiated outwards, so it doesn't actually hit the tip. So an evolution to that, okay, is the newer ceramic heating elements with the interchangeable tip. So the heater is inside the tip, okay. So as heat radiates out, the tip absorbs all of the heat. So if you imagine, if let's say in a factory or in an assembly line, hundreds of those soldering irons are changed to a more energy efficient one, right? So
Yeah.
that would be a lot of savings for the factory.
That's
Yeah.
the
So
cartridge type tips.
yes, that's right. Hmm. Oh no, the cartridge type is even newer.
Oh, okay.
I was referring to the one with interchangeable tips only. The 936.
Okay, the T series
Yeah, the T
tips.
series, right? Okay.
Went from hot air to regular soldering stations,
Yeah.
and then it's kind of expanded to more
Hmm.
complex models, right?
One of the bigger machines we have developed and are selling are those BGA reworking system with the split type vision system, wherein you can see the BGA and the board so that you can align the BGA to the board before using an IR lamp to resolder it. Yeah.
What would you say are like the most popular stations?
Before it would as when it was starting, of course, the most basic 850 and 936, 850 hot air gun and 936 soldering irons. But of course, as the electronics and miniaturizations keeps on advancing, so now the 9378 Pro, the soldering station, the 9378 Pro, uh, which has lots of intelligent, we call it an intelligent soldering system because it has um, lots of or tons of functions like sleep, quick jump, digital offset, and it has also tool recognition, right? So
Yeah, one of the coolest things about that is you can have a lot of different soldering tools, different handles you can plug into it.
yeah, that's right.
There's like the
Before,
LED iron, the cartridge type, the regular one,
mhm,
the 3D sculpting tool, macro
yes.
tweezers, now micro tweezers.
Well, before the 1978, you would need at least one, two, three, four, five, at least five different stations to have all
Yeah,
those tools.
to do all
9350
of that.
for the two turns, 936 for the T-type tips, the 2900 for the cartridge type tips, right?
Do the tools run at different like voltages?
Use lower, some systems use higher voltages. Okay. But what is important there is that for those high end, higher end soldering systems, they use uh, either DC or AC that is lower than 36 volts, which is the uh, industry standard safe low voltage uh, uh, low voltage standard that is required for consumer use.
Oh, 18 volts is like standard.
Lower than 36 volts is the standard.
Okay.
Okay. So if you go 18, 24, it's okay.
Yeah, another thing I really like about the 9378 Pro is the plug-in heating elements.
Hmm. That's what we call the WQ tips. Is that the cartridge type?
The actually the regular one for the T series,
Uh huh.
but you can
Oh, okay.
actually plug it
Oh,
in
that
and
one.
unplug
Okay.
it instead of having another soldering iron to replace your
Right. Okay.
heating
So
element.
that was way before, right? When the initial 936 was introduced. Okay, the tip was actually soldered to the handles PCB board. So when you need to change the heating element, you need to get another soldering iron
Yeah.
to desolder the heating element. But
That's,
now with the newer system, of course, you don't need that. You just can you just it's a cartridge type. You just uh, plug it out and then plug in the newer the new heating element.
yeah, love that. More of those and transfer all of them over to that.
Yeah, which is also easier than the extremely old one, the one which I said, which I call is the external heating element, because for those with the external heating element, you still have to unscrew the tiny screw on the tip before you can pull out the old uh, soldering iron tip.
Well, speaking of soldering iron tips, um, could you give us like a little rundown of the different types of tips and their uses?
Oh, okay. So one of the most versatile tips I can tell you, okay, is the knife tip. Okay, and there is actually two kinds of knife tip. Okay, there's a tip for the right-handed people and a tip for the left-handed. A lot of people don't know that.
I
Actually,
didn't
the
know
tip,
that.
yeah, the knife tip has a right-handed version and a left-handed version. Okay, so it's just it does it is just a difference between the angle of the knife actually. Okay, so but both works well. Of course, it would be much better if you're left-handed, then you have to buy the left-handed version. Okay, okay. So for the knife tip, why did I say that it's the most versatile? Because in our factory, our in our assembly line, or the ones doing the board, they just need one knife tip to do most of their work. Of course, if you're reworking or resoldering some other micro components, you may need the other tips. But for in our factory during our assembly, we just use the knife tip, because we can actually use we could drag solder with a knife tip. Okay, we could use a knife tip to wick away excess solder. Okay, it the issue there is the personnel doing that thing has been doing that for more than 10 years, 8 hours a day. So
Yeah.
so they can do miracles with a single knife tip. But of course, for us, which do just occasional soldering, right? Or we need a more precision, or we're doing some more precision work on miniature components. Of course, we may need those highly needle, well, what I call them needle type conical tips. It's especially suited for those using what do you call it? Magnifying. We have one of those, but it got discontinued. The one that magnifies the component. I don't know if you've seen one of those. What do you call that?
Um,
So
so
it's a
just like a
camera, yeah, a camera
right.
and a screen, right? And
Yeah.
it magnifies it up to 80, up to 100 times.
Digital
There, you would need
microscope kind
those.
of thing.
Yeah. Then there you would need those needle type tips, right? And then for us common folks, which can't do miracles with knife tips, we may need those conical or those we call them hoof types
The bevels.
bevels, yes, with the tunnel inside. Okay, so it's actually there's actually it is actually bored such that it has a little indent on the tip,
Yeah.
such that when you clean it, it's gonna be clean, right? And then when you touch the solder, it's actually gonna suck the solder up to wick away the excess solder for those SOP ICs which you're working on. Okay. Okay. So those are some
So
common
you're
uses of the
so
tips.
it solders the component pin, and then whatever it doesn't use gets sucked into the tip,
Yes,
basically.
that's right.
There's also the chisel.
Yes, and also the chisel one. Chisel one you use for high or large ground plane soldering. That you need a bigger tip with a larger contact mass, such that when you uh, especially when you're soldering those power ICs, those what do you call those IRFs with those large heat sinks. Okay, so you will need that.
Yep. Bigger surface area, more heat transfer. A lot of people seem to like the curved tips, the J.
O2J, I think.
Yeah.
Yeah, because it's one of the uh, what do you call? It's not called sharp, right? What do you call it? The smallest tips with small tip, and plus with the bent, it actually you could actually reach uh, components which may be out of reach for normal straight tips. Plus, it doesn't what do you say obstruct your view when using that kind of tip.
Oh, that's true. I didn't even think about that. You can kind of see straight down.
Yeah. Mhm. When it's straight down, it would because the tip is very what do you call small, right? Okay, but the
Yeah.
body of the soldering iron is much larger compared to the tip. So when you have that O2J one, the bent one, so it let's say nudges out or spikes out, so you could see much better with it.
Yeah. Um, Great for like small SMD
That's right.
components with the soldering iron.
Up to zero point. I don't know the American uh, uh, how do you go model or 805 SMDs, those smaller ones. Okay,
Yeah.
in
It
the
might be the
US,
same.
yeah,
I'll I'll
because
I'll find it
for
and put
the
it
for
in.
for international standards, we call them 0805 SMDs. But US, you have another notation for it because US is not in a metric, right? You're still using
Right. We're
imperial,
we're
right?
special over here. Yep.
Yeah.
Do you have any soldering iron tip maintenance tips?
Well, one of the most important one is to keep your tip tinned. That will make your soldering iron tips last much longer. It's uh, keep the temperature to a minimum. Okay, so if you're using actually standard solder, I think in the US you still are allowed to use the standard solders which have lead in them, right? Okay, so if
Yeah,
you're actually using those,
I
okay,
use them.
you don't need to set the temperature too high, right? So just set. Oh, one more thing. Okay, if you have, let's say, a standard solder which melts at around 180, 185. Okay, it doesn't mean that you have to set your soldering station to 180 and 185. That would just barely melt the solder because you have to in terms of thermodynamics. Okay,
Yeah.
the tip. Okay, just imagine the tip is 185, right? Okay, and you need 185 to solder to melt the solder. Okay, so once the tip touches the solder, okay,
It's
immediately
no longer 185.
yeah, it's not going to be 185 anymore, right? Of course, the system will notice that it has dropped and then pump heat back in, but you're not going to get an effective solder there, right? So you have to
Yeah.
actually set the temperature a bit higher. So for normal or standard solders, temperature of around 300. Okay. Well, actually, it depends on your systems. If you're using the normal 936 types, around 350. But if you're using the higher end one, like the 9378 with the WQ tips, 300 is enough. Okay. Okay. So that's one. Okay.
Yeah.
And then, of course, keep your tips tinned. Okay. Because if you're using the let's say lead-free solder, wherein you have to set your temperature to around 350 and sometimes 380, okay, depending on the lead-free solder you're using, okay, the lead-free solder actually oxidizes pretty fast, okay. So if you leave it without not leave it untinned, okay, the tip would oxidize very quickly and it would turn yellow and then black. So lots of people would be complaining, "Oh my, this thing won't melt my solder. I have set it at 400 or even higher. It's just not melting the solder." The problem there is the tip has oxidized, so you have to clean the tip, retint it before good thermal conduction would occur, and then you would have a good solder joint.
Yeah.
Yeah.
You can't destroy it and then expect it to work.
Because some do say, "Oh, I have it at 480 and it's still not melting." Well,
Yeah.
or they would have the difficulty because the tip would be, let's say, partly oxidized, so there would be just a smudge there which could actually transfer the heat to the solder, right? Okay, or to the solder joint. Okay, so they would be having great difficulty doing a good solder job with that if you have a badly oxidized tip.
Right. So what's a tip comprised of? Or made of?
The tip, yes, the tip is actually the main metal there is copper. It's the cheapest one with the highest thermal conductivity. We need a high thermal conductivity materials or metals so that the heat that is generated from the heating element would be quickly transferred to the tip, okay, or the copper tip. But then again, one of the problems of copper is you would see it's a nice brown color, but once you heat it up, what happens? It changes color quickly. That's the tip oxidizing, right? So to prevent that, okay, we have to uh, what do you call it?
Plate?
Electroplate. Yeah,
Yeah.
plate it with other metals so that the copper would not oxidize or would not be exposed to air, okay, and not oxidize, okay. So there are several electroplates there. One of which is actually we plated with iron. Okay, so copper itself is a bit it's what do you call malleable metal, right? We need a stronger one, so that is one of the things you might know is notice for old tips is they start to bend, right? The tip starts to deform. Okay, that's because the iron plating has been eaten up. Okay, so it starts to get soft. Okay, so we have copper, we have iron plating, and then we have also the nickel plating, so that it doesn't part of it doesn't what do you call it, get tinned. Okay, so we just uh, tin the tip. Okay, tin the tip. Okay, tin the tip of the tip. Okay.
You played it with tin, right?
Okay. We played the tip of the tip with tin, but the rest Is not. Okay. So that would keep your solder only on the tip.
Yeah, and we call it tinning just because solder is mostly tin.
Yeah.
You're just kind of adding solder to it, or a mixture of metals that includes tin
Hmm.
to replenish the tip. What are some of the benefits of using a brass coil cleaner versus, a wet sponge?
Well, first is, of course, when you use a wet sponge, the drop in the tip temperature would be much larger than compared to using a brass, the brass one, right? Okay, and also that sudden change or sudden drop in temperature would put stress also on the tip. As you know, metals have different melting point, and if you have such drastic change in the temperature, okay, those electroplating, if it's a chip kind of tip, those would peel out, right? Okay, so of course you don't want to do that too much, right? However good the electroplating is, if you mistreat your tips, it's gonna go it's gonna break
Go
much
south.
easier, right? Okay, so but of course, if you're using a brass one, right, it's a low abrasive brass cleaner, right? So none of those. If even if it has a slight lowering of the tip, it's not uh, as much as the sponge one, right? Okay, so that's one of the reasons why it's much better to use the brass tip cleaner.
Yeah, I like that you can keep working and clean your tip and keep working
Yeah,
without having to really
you don't have
stop.
to. Don't have to wait for the tip to come back to its optimal soldering temperature.
Right. I personally I prefer to use a combination of the two.
Hmm.
Use the coil cleaner until unless it gets like very heavy with flux residue. Then
Yeah,
I like
that's
to use
right.
the wet sponge because it cleans a little bit better
That's right.
with that
That's right.
tough stuff on it. So I think I think they make a great team together.
So, one of the issue there, you were saying that the sponge cleans much better. It just cleans too much, such that all of the tin gets wicked out of the tip. So if you're not gonna continue soldering immediately, there's a chance of it oxidizing the tip. So that's why it's also much better to use a brass. The brass one, it doesn't uh, clean all the tin out of the tip, so it leaves a tiny amount there, just enough so that you could continue your soldering.
Okay, so it kind of helps you tin your tip
Yeah.
basically because you're plunging it in and there's solder and tin in there too that gets
Right.
trapped, so you're kind of like keeping it tinned but still cleaning the bulk of it off
Mm-hmm.
with the coils.
Yeah, that's right.
Maybe we could talk about soldering safety
Yeah.
with
Okay.
like fume
Uh,
extractors and
I forget, is OSHA in the US?
yes.
Yeah. Okay. So one of the issues with soldering is there are fumes when you solder. There are chemicals you use uh, during soldering, right? Okay. So uh, as as we learn more about the hazards of these things, okay, we also Aoyue also produce some equipment which would uh, aid us in, let's say, extracting or um, what do you call it? Is it
Removing.
called moving fume extractor? Okay,
See.
so one of the most basic one actually, which most of us do, is to, when we solder, we after soldering we face away. Okay, so that we don't
Yep.
breathe the fumes. Okay, either that or we have a fan right beside us, or a small one, right?
It's
But of course, that would cool down the tip of the one we're soldering too much. Okay, so one of those products we have on the market that would aid us that in let's say moving those fumes away from our work area is the 486, the most basic one. It's a fan with a carbon filter in front. Okay, so the carbon filter would catch some of those particles and then blow it away from your work area. But of course, an advancement of that is the 486 plus. Okay, now the 486 plus has a, let's say, a, what do you call that, tube,
hose
exhaust tube.
vent.
Yeah, an exhaust tube which you can actually direct the fumes or out of your work area, maybe outside of your home or into your, if you have a exhaust fan, right, you can actually attach it there. Okay, so
Right.
but of course those are just actually moving the fumes from one area to another. Okay, so an
Yeah.
advancement of that, yes.
It seems like when I'm soldering, the fumes are attracted to to heat, kind of.
The
So they
fumes.
like go right to your face.
Well, well, could be because we're inhaling, right? So that small gush of air, right? That when we inhale, it
Yeah.
attracts the smoke. Yeah. So anyway, so but that those kind the 486, 486 plus, uh, of course helps us in moving those fumes away. But a much better tool would be the FEK -01. Okay, so that's actually this system actually has a HEPA filter in it. Okay, and also a um,
Carbon.
an actual carbon side or carbon bits inside. Okay, carbon bits, because for the 486, it's just it's a sponge with activated carbon. Okay, so it's an activated carbon sponge. A
Right.
much better absorption of those toxic particles would be actual carbon beads. Okay,
Right.
so in the FEK, you have a whole, I think it weighs almost a pound does it weigh almost a pound? I'm just guesstimating because pound and kilograms.
Right.
Okay.
You can give it to us in kilograms. That's fine. We'll figure it
Okay.
out.
So it's almost a pound of actual carbon beads. Okay, so that is designed using a, let's say, what do you call that, a honeybees, uh,
Honeycomb.
honeycomb. Yeah, there you go.
Honeycomb.
Honeycomb. Okay, with a honeycomb enclosure, so that would maximize the absorption of the toxins uh, in the air. Okay, so what happens is the fumes, okay, get sucked in with the hood. Okay, so our hood has a LED light there. You can turn that on and off. Okay, and then, which I think as of now only we have that, right? The one with the light and
I
the hood.
think so. It's usually just a plastic opening.
Yeah. So
And the
and
FEK has the 486 filters
yes,
on the
on the
in hose.
so that's so actually we in addition to that, right? So we have the HEPA filter, okay, and also the carbon filter, right, below. Okay, so you're getting much more or better efficiency in filtering out those fumes.
Right. I'm using one in my basement right now that doesn't really have any windows, and it works pretty well.
Yeah, that's right.
Well, thanks for sharing your knowledge with us, Wilbert. I hope to talk to you again in another session like this. And if you guys have any questions for Aoyue that you'd like to have us cover in the next video, let us know in the comments below. All right? Thanks.
Thanks. Bye-bye.